In the last video, we did a quick review of the exponential and what it means, and then we looked and figured out what the magnitude of an exponential is. The magnitude is equal to 1. Now we're going to look closely at this complex exponential as it represents a cosine, a part of a cosine. Now we're going to keep combining some of our ideas from the last couple of videos. And you remember, one of the things we did was we used Euler's formula and turned it inside out and developed an expression for cosine. So if I say cosine of theta, I can say that equals 1/2 times e to the plus j theta plus e to the minus j theta. This is cosine of theta expressed as two separate exponentials. And now we're going to take a really special step. I'm going to put in an argument right here of time. I'm going to say cosine of omega t. T is time, and this shape here, this symbol here is the lowercase omega from the Greek alphabet, and that's the frequency. So time is in units of seconds, and omega is a frequency, so it's in units of 1/seconds. That's the units of frequency, or per seconds. And when these multiply together, we get dimensionless number right here, and we can take the cosine of a dimensionless number. So what does this equal to? This equals 1/2 times e to the plus j omega t plus e to the minus j omega t. When we make t the argument of the cosine here, t is this stuff that keeps going up and up and up. The number t just gets bigger all the time. And so we ended up with a cosine wave form. And I'll just make a bad cosine looking thing here. That's what a cosine looks like. And it keeps going and going and going. So we have an idea of what a cosine wave looks like. The frequency determines how fast this goes up and down, or how often it goes up and down. But now what I want to do is I want to look at a really special thing. I want to look at, what is this thing right here? What is this thing, e to the plus j omega t? And what we see is this cosine here is made of two of these things. So whatever these things are, I can make a cosine out of them. So now we're going to look really carefully at e to the j omega t. What we just reviewed was that this is a complex number. Let's draw that complex number. So we're going to put a number out here. We know it falls on the unit circle. We know its angle is whatever is multiplying the j up in this exponent. Whatever's up in the exponent is the angle of this thing. So this angle right here is omega t. And we know the magnitude of this is, as we decided before, the magnitude is 1. That's why it falls on the unit circle. Okay, so now look at this. Here's this number t that's determining the angle. And that means what? That means that the angle is increasing with time. If time is equal to 0, the point is right here at time equals 0, because angle is 0. As time proceeds, the angle starts growing and growing, and it basically keeps growing and it keeps going. It comes back to here after omega t equals 2 pi, and then what happens? It keeps going around it again. And this basically goes along for as long as time goes along. So here's this number. Here's this complex number moving along the unit circle in time over and over and over again. So this is a number that is rotating. The number is rotating. So I can write here e to the j omega t, and I know that because time's up here, I know it's rotating in time. All right, now I'm going to put a different number on there. Let's put it over here, say. Well, let's actually start this number at 0. And I'm going to call this number e to the minus j omega t. What does that number look like? That's this guy here. That's this one here. We'll make him orange. So at time equals 0, it's e to the 0, or 1, just as we would expect. Now, as time gets bigger, the angle, the thing multiplying j, is minus omega t, and so the angle is becoming more and more negative. So after a little bit of time, it's here, and after a little bit more time, it's here, and what we notice is it rotates this way. This is what happens when you have e to the minus j omega t. You rotate in this direction, and it keeps going and going and going. So these two numbers are pretty similar in behavior, except one rotates counterclockwise and the other rotates clockwise in our coordinate system, which is the complex plane. So in summary, if you see either of these shapes, e to the minus plus j omega t or e to the minus j omega t, what pops into your head is a number that spins. So for me, the simple idea is I have a number here and I have a number here. They both spin in a complex space. And to represent those in mathematical notation, I need this kind of notation here, which is a little bit awkward. But as I get used to it, e to the j omega t is a spinning number. E to the minus j omega t is a spinning number. This is an amazingly powerful idea, and we'll be able to describe every signal that happens using these kind of terms.